Hi everyone, hope you've had a great day today so far listening in on all the sessions. My name's Pavan. I'm a software development engineer at AWS. I'm also a maintainer of the ML Commons plugin on OpenSearch. So in today's topic, we'll be looking at and learning how one could leverage the power of agents to perform rapid root cause analysis, right? But before jumping into this, let's take a look at a scenario, right? I'm sure all of us have been in this situation at some point in our life. You're having a pleasant sleep, you get paged at like 1 a.m. or 2 a.m., you're on call, you gotta wake up. You don't wanna wake up, but you gotta wake up. You force yourself to get out of bed, you look at some metrics to try and understand what went wrong. Did something really go wrong, or was it like a false alarm? Then you pull up some logs, you pull up some traces, right? You come up with a hypothesis that could have caused the problem. Hopefully, you find the root cause, you mitigate the issue, and call it a night, right? But the sleep when you go back is not really convenient because you're worried about getting paged again, right? So in this talk, let's focus on how we can mitigate some of the pain associated with this scenario and how one could potentially make their lives easier, right? If you couldn't tell already, these images were generated using AI, but let's take a look at how you can use AI to do some more. So the agenda for today will be, we'll be going over a typical root cause analysis workflow. We'll be looking into agents, some of the building blocks associated with agents. We'll go over a quick demo. We'll look into some of the challenges and strategies you can use to improve the accuracy of such agents. We'll look into how this can integrate into the future and how it can help mitigate some of the pain, and then we'll just have a quick Q&A session. So a typical root cause analysis workflow involves something like this, right? An alert gets triggered. You look at some metrics, try to identify what went wrong. You look at some logs, you try to identify why it went wrong, and then you come up with some sort of hypothesis, and done, the root cause has been found. But it's rarely as easy as it seems, right? It's never this easy as it seems, and there's quite a few pain points that are associated with this. Well, first thing is you got to perform complex cross-system reasoning under time pressure, right? You're trying to mitigate issues very quickly, and you're trying to make sure that the system or whatever is wrong comes back up as soon as possible. Second thing is the data is siloed. You have metrics, you have logs, traces that probably live in separate systems. And do you have the context and the capability to know all these query languages and look and query for the right data to tell you what went wrong? Third thing is it's manual, it's time consuming. How can we reduce some of this effort, right? Fourth thing is it's context dependent. What if you get paged on a system that you have no idea about, right? It's your first on call. You look into some services and you don't know how the service functions, right? How are you expected to root cause? Are you going to page a senior developer at like 2 a.m.? Well, I mean, in the worst case, you might have to, but hopefully not. The last thing is it impacts quality of life, right? We saw in the first diagram how it's hard for someone to potentially go back to sleep because you're worried about being paged again, and it has affected your sleep cycle, right? So what if you didn't have to go through these pain points, right? What if you had a system that could help you, sit with you, act like a co-pilot in answering some of these questions, right? An ideal scenario is, well, you have a system that helps you do the RCA itself. Hell, you have all the data. Why don't you also build a system that can read the data, understand it, and give you some guidance on how you can solve such problems, right? And how can you achieve that? Well, you can use agents to do that, right? This is a typical agentic architecture. You have an LLM, which acts like the brain. You have built-in tools, which gives functionality to the agent. You have an actor, which is obviously providing the question or the details or context about the system. You have MCP, which is a protocol that allows you to talk to multiple data sources. And finally, you have memory, right? What is memory here? Well, it's used for persistence, it's used for recollection, it's used for storing your chat history and also long-term facts, right? There's typically two types of memory. You have short-term memory and you have long-term memory. Short-term memory is typically your chat history, whereas long-term memory is facts that have been extracted from your conversation, right? And when it comes to building an RCA agent, what is critical? It's context, right? Context is everything. That's where we come into the pillars of observability. You need metrics that can be stored in various systems, Mir, InfluxDB, Prometheus, Logs and traces could be stored on Loki, Elastic, OpenSearch, Tempo, right? You need to provide all of this context to the agent, right? And how do you do this? Are you going to sit and build out tools for every single system that is out there? That's not reasonable and that's not scalable, right? So, well, you use the power of MCP. This is something I touched on earlier, but MCP is just, I think all of us know about this so far, is a model context protocol. It's an open standard that allows connecting your LLMs to external tools and data, right? You have a server that follows a certain standard. You have a client that requests for data and the server responds in a certain format, right? So you no longer have to go and build out all these adapters. Instead, you just have one universal adapter that plugs and plays into system, right? This is so simple and it's standardized, right? Now that we have kind of established agents and some of the building blocks that might be core components for RCA, let's look at what is a typical workflow for building agents. First thing is you want to define your success criteria. You want to establish clear goals for your agent. How do you know it's performing well? How do you know its accuracy is right? How do you know it's giving you the right reasoning, right? You want to define this and clearly establish your goals so that you can evaluate your agent, right? Second thing, pick your stack. What agent framework are you going to use? You have OpenSearch, you have Strands, you have LangGraph. What memory component are you going to use? You have memory, you have, again, agent core runtime, right? Then what LLM are you going to pick? You have GPT, Claude, Gemini, Grok. Then when it comes to tools, are you going to build your own tools or are you going to leverage MCP? How many tools are you going to give access to your agent, right? Then the third step is very critical, is tuning. You want to tune your prompts, your user prompts and system prompts. You want to tune your memory, right? How much history in a conversation do you want to share to your agent? Do you want to share facts to your agent, right? And last one, which is very key again, is how much data do you want to pass to the LLM, right? You can query any metric system or any trace system and you can end up having like thousands of records. It's not feasible for you to send all this raw data to an LLM because the context window is limited, right? And the last step, what you want to do is you want to benchmark and you want to iterate, right? This comes back to the success criteria that I spoke about earlier, is you want to benchmark against this and you want to continuously tune and iterate and assess your agent's performance, right? So before we kind of jump into the demo, I want to preface some of the architecture and the stack that has been used here. Today we're using Prometheus for metrics, and I'm using OpenSearch for logs and traces. This is the architecture of the application and the demo today. We have the OpenTelemetry demo application that uses the OpenTelemetry protocol, pushes metrics to the hotel collector. This emits the metrics to Prometheus. Then you have logs and traces that are being ingested into OpenSearch. Now, all of this is being accessed via the OpenSearch agent framework that we're using here today, and we are specifically using the PER agent and we're using the Claude 3.7 Sonnet model, right? So this OpenSearch server connects to both OpenSearch and my Prometheus cluster and now has access to all the data that it needs to perform the root cause analysis, right? Awesome. Now I want to quickly showcase how anybody can kind of set this up on their own and, well, have fun with it, right? Cool. I hope you can see my system. So I have the OpenSearch cluster running here. This Docker application is running the hotel telemetry application. It's just a shopping cart, right? You can buy some items, you can add some items to your cart and so on. I have a feature flag set up here which fails the cart service. This essentially, when you try to empty the cart, it does not do anything, right? Now let's see how you could set up your agent to kind of automatically root cause this, right? First thing is I have a Prometheus server here, Prometheus MCP server, and an OpenSearch MCP server. It's very simple to set up. You just need to provide your URL, provide what transport protocol you're going to use, what port you want to bind it to, and then just run the server, right? Similarly, when you set up OpenSearch, all you need, the OpenSearch MCP server, all you need is your URL, your username, your password, and then you just run the Well, you just run the server, you specify what protocol you want to use. In this case, we're using the HTTP streamable protocol. Awesome. Now we have a Prometheus MCP server setup. We have the OpenSearch MCP server setup. Both of them are talking to the application which is pushing data to Prometheus and OpenSearch. Now let's look at some of the data, right? So these are some of the metrics that are available on the system. I just ran this, right? Great. Now let's register the MCP connector. All of this is using OpenSearch's inbuilt agent framework. So most of it happens through APIs. There's no code involved here. So you set up where your Prometheus server is running, which is running on localhost 8081, which we saw here earlier. You create the connector. You just take the ID. I'm going to go through it with you all. Then you want to similarly register the OpenSearch connector. Again, OpenSearch MCP server is running on now this port. Create. I'm going to copy this over here. Then you want to register a model, right? You just use this API here. You want to specify what model you're using. In this case, I'm using the 3.7 Sonnet model. You provide your credentials. I've hidden the credentials for now. You provide the URL, and you provide the request body that is required. So this is very generic in the sense it supports any LLM that you want to use, right? You can register the model, but I already registered a model earlier with my credentials, so I'm not going to be using this. Then you simply go ahead and register your agent, right? Here, this is the agent I mentioned earlier, which is called the plan, execute, and reflect agent. You specify the model ID that you want to use. You provide your MCP connectors, which we created earlier. You define your LLM interface, which was, in this case, we used Claude. This is some context engineering stuff I can get into once the demo is done. Then you register the agent, have the agent, and you execute it, right? But so the question here is, hey, my empty cart functionality is broken. My users are not able to empty their cart. Can you identify the root cause for me, right? Use Prometheus metrics and OpenSearch logs and spans to root cause the issue. So let me just pick up the agent ID and execute this. So this is actually a long-running agent. It takes about 5 minutes to run. You can pick up the task ID and you can query this to poll for the final result. But in order to save time, I actually ran this earlier. My token has expired. That's okay. Yeah, so let me pick this task ID. And you can do a get task, and you can actually look at all the actual root cause analysis that you got, right? I've neatly written down here. So the agent comes back with a pretty comprehensive review. It says, after a comprehensive investigation of the empty cart functionality, I can report that the root cause has been identified. Below is a detailed analysis of the findings and the steps taken to identify the problem, right? The summary of findings is that is an intentional enabled feature flags named cart failure. The agent is smart enough to kind of look at the traces and identify that it's actually a feature flag that is kind of causing the issue, right? It's consistently on while cart operations continue to work normally. And it gives you a step-by-step details of exactly what has happened, right? Identified available cart-related metrics, app, get cart, at item, no specific metrics for empty cart, confirming absence of empty cart metrics. Then it tries to analyze some errors. Then it tried to examine some error patterns over time. All empty cart operations were failing. Now, after it has validated that the issue exists via Prometheus, you can see how the agent is smartly jumping to OpenSearch to try and investigate the root cause itself, right? Checking for related logs in OpenSearch, verifying service health, investigation Redis operations, right? So what the flag actually does is it breaks the connection between Redis and the cart store. So this is the exact root cause that has happened. Once it has identified this, it actually then correlates this to the feature flag service, and then picks up the fact that the flag is exactly causing this issue, right? So I ran this another time as well, and you can see how it analyzed the traces in the index, how it used OpenSearch Prometheus metrics to find out the root cause, and it also kind of came back with the system architecture notes, right? So immediate solution is to disable the cart failure feature flag. right? So this is very cool, right? I didn't have to query any metrics. I didn't have to query any logs. Hell, I even created the model and the agent within 3 minutes, and I triggered an agent execution, right? So this is very cool, and it kind of takes away a lot of the pain that you would have when kind of root causing issues. So yeah, that was the demo, and I would like to kind of get a little bit deeper into what the plan execute reflect agent itself is, right? I know I just used it just now, but it's a smart agent that has two phases. It has a planning phase and it has an execution phase. It performs self-evaluation. It allows you to have separate LLMs for planning, separate LLMs for execution, allows you to control your cost structures, right? You can pick a stronger, faster model for planning. You can maybe pick a cheaper model for execution. It performs context isolation, auto tool selection. It's a long-running asynchronous agent. It has inbuilt function calling. It allows you to control a lot of the prompts, and it has flexibility to pick whatever LLM you want to, right? Looking a little bit into the workflow, the way it works is the user gives you a task, the agent receives the task, it forwards the task to a separate planning LLM. What the planning LLM does is it just comes back with you with a series of steps you need to execute to potentially reach the final result, right? But note, at this point, the agent has no context about your system. All it knows is the task. So it comes back with the first step. This step is then forwarded to what we call the React agent. Ignore the name. I know it says deep research agent, but that was what we called it earlier. Then we moved it to plan, execute, and reflect. So it passes the first step. The first step gets executed. You get the response. Now, this is the reevaluation part or the reflection part, wherein you pass the original plan along with the executed step to reevaluate on the plan, right? So take an example. I'm an agent. I don't know anything about your system. My first step, more or less, when it comes to talking to OpenSearch, is going to be list indices, right? Then only then am I going to get the list indices, and only then am I going to know which exact index to query. Same thing applies to Prometheus. I list the metrics first, only then do I know what metrics to look into. So a simple, smaller agent cannot plan the entire scope or the RCA process. But when you separate this out, you can see actually stronger results coming out, especially when you have a lot of context. So some of the challenges and strategies that you can use to mitigate this, right? The first challenge is benchmarking. Benchmarking is very difficult to do, especially because of the subjective nature of the LLM responses. How are you going to evaluate a response that is changing every time? I showed you in my example, the first task showed something different, the second task showed something different. So most of the times you need LLM evaluators, right? It's very hard to quantify this simply because of the subjective nature of LLMs, right? But what you can quantify is querying. What you can do is you can make your LLMs and models tuned very well to perform queries, right? You can give it a natural language query and you know exactly what type of query to expect. Second thing you want to be careful about is context pollution, right? You want to control the amount of data that you're providing to the LLM so that it doesn't hallucinate, so that it doesn't come up with wrong information, right? Because it's very critical for RCA process. You can't just agree with what an LLM tells. It definitely hallucinates. And some strategies for tackling that is try to summarize raw data. You can prune tool outputs, right? When you query something large, you can't push all the 1,000 records to the LLM. You may want to give 10 at a time, 20 at a time, right? Perform context isolation, perform self-evaluation, have automated prompt construction. Then prompt engineering is also difficult. It's not as easy as it sounds. So always go back to the LLM that you're using and the providers that actually have guides and suggestions on how to go about this, perform A/B testing. And visibility is again very critical, right? How do you know if what your agent or what your LLM is telling you is right or wrong? This is exactly why memory is very critical, because it stores every request response within your application. Tracing is important. You need to capture every step of the process. Right? So how can you extend such a system, right? You can add more data sources. You can use something called agentic memory, where it automatically identifies the necessary facts that are required to kind of improve the performance of your agent. You can do context management. You can build specialized sub-agents. For example, you can build an agent that only has access to OpenSearch tools. You can build an agent that only has access to Prometheus tools. That way, the tools are not populating or polluting the context window. Each agent has specialized on a particular system. You can provide knowledge bases about your application. You can provide service architecture diagrams. So what are some key takeaways from today is, first thing is build on top of data sources, right? Agents and MCP are very powerful, right? Visibility is critical because you need to know what has happened in order for you to believe what the agent or the LLM is telling you, right? And fourth thing is the LLMs are not strong enough today where they can do everything on their own. Think of them more like your co-pilots and kind of not your autopilots, right? So how do I see this kind of applying in the future, right? So the way that I visualize this is the application, obviously you're capturing metrics. It's probably going to trigger some sort of an alert. The alert is going to send the details of the alert to your root cause agent. Your root cause agent is going to pull in all the data from data sources, perform its own analysis, and only then page you with its necessary hypothesis, right? And then in an ideal scenario, it has identified what has gone wrong, and it's also providing you with the mitigation steps. And all you have to do is accept or reject, right? Or guide the agent to do some more root causing. And then if you do accept, right, your typical or your final result, all you have to go do is the agent has to just mitigate the final response. And this you can do by providing more tools, right? I know I spoke a little bit about memory, but I didn't really jump into and show the traces itself. So for my task here, you have this memory ID. I just want to quickly show you guys how this would look. Right, you take this message ID and then you fetch the traces, right? So you can kind of look at the step-by-step details of how the agent actually resolved this issue, right? It says use list metrics tool to identify available metrics in Prometheus that might be related to cart functionality. Use list metrics again for empty cart or clear cart. Use execute query tool for general error rates. Execute, again, there's a range query tool. So here you can see kind of step by step how the agent has gone about performing the root causing. So yeah, that's about it. Thank you so much. Hope you all learned something from this.
Thank you. Questions? Oh, there's one. Okay, go here first, then pass it to.
Thank you. Thank you for your talk. It was very interesting. I wanted to dive a bit more into the memory usage, because what you showed last, I would assume that's kind of the chat history between the different agents. But how does the long-term memory come into play? Like, is this kind of a knowledge build, like where you build and store knowledge, but you can reuse across rounds, or like how does this work?
Yeah, that's a great question. So in the demo that I showed today, it's a simple chat history. We're not using any long-term memory. But when it comes to long-term memory and how you would use it, it's typically you have an LLM that is continuously reading your chat history. Based on your chat history, it's extracting some facts. So for example, in your conversation, you can say, I like the color red. Now what the agent does is it pulls this information, it stores it as a fact called I like red. So the next time you ask like some questions about what do I like, it's not only referencing your chat history that might have been removed from that session, whereas the next time you ask it, it can go fetch from like a data store and then tell you that, hey, I like red. Now, how can you use this? You can use this as, like, for example, right, in this agent, it did a list index, right? Now it knows all the indices, and that's a fact. Now I can store this fact. The next time I don't have to do that list index. So that's how I would see kind of long-term memory stepping into this scenario.
All right.
Hi, I also have a question here.
Hey.
Thank you for the talk. So have you tried running this with any success against actual production issues?
Sorry?
Have you tried running this flow to debug actual production issues with any success? Because usually in real applications, we don't have like fail card feature flags to tell us to fail something.
Yeah, makes sense. So this is like a proof of concept that we have right now to try and resolve these issues. It's soon being productionized, and we have like a real life use cases. And we actually do a lot more context engineering than I did here. The agent exposes the prompts that you can tune. The agent exposes context engineering flags about how many tools you can provide. We also have specialized sub-agent architectures. You don't just have the planner and the executor. You actually have one planner and multiple executors, right? So when I say it's this is a good positive use case, and there's a reason I picked this, because maybe it works maybe 60-70% of the time. And the important aspect here is it definitely hallucinates, but you can ask follow-up questions on the investigation itself, and that allows you to validate your hypothesis, right? This is why I said like visibility is kind of very critical, knowing what steps has performed. You can even look at the raw tool results of the queries, so that should give you some good insight, right?
Hi, thanks for the talk. I'm just wondering, like when you say filtering data, let's say from Prometheus, how would you exactly filter it? Like, do you use some sort of like relevance mechanism, or is it just
Sorry?
filtering by chunking the metrics?
So again, rather than, so you can do a couple things. You can do, first thing is here we are relying on the intelligence of the LLM itself. So it kind of comes up with the query on its own. The second thing is there's a context management strategy called pruning, where what you can do is when you get the final result of the tool, you don't provide the entire tool output to the LLM itself, because that would eat up a lot of the context window. So you can prune a particular part of it and kind of paginate on that result to provide small aspects on it until it kind of improves on the querying. So querying has been a big challenge. So we had to build a custom model that kind of is capable of querying well enough, because otherwise what happens is it tries to come up with the right query in one shot, then it realizes the query is wrong, then goes broader and broader and broader until it gets some results and understands the data, and then starts going specific again. So you want to kind of stop that cycle.
Yeah, so like when you say custom model, you mean like a custom trained LLM?
Not an LLM, like a model that has been trained on querying itself.
I see.
So
Okay, thank you.
Hello? Yeah, hi. Right here. Great talk. Thank you very much. I'm kind of jealous of your job right there. My question pertains to MCP and more on the security side of things, which I'm sure you know it's quite a topic currently. As far as I understand, at least, it's not a solved problem yet, especially when it comes to logs and prompt injection. What are some mitigating strategies there that you, based on your experience, could talk about a little bit?
Yeah, a couple things, right? So first thing is we have certain guardrails wherein, like, when you provide certain terms and certain words, the LLM outright refuses to answer, right? We have also basically we take away those words and we completely replace them, or we just say don't answer to this kind of question. But when it comes to security, that's something we're trying to figure out, because more often than not, you don't store all your data in a single cluster, because people have a lot of applications. And currently the way MCP works is you set it up and set up the environment variables to talk to one cluster, right? Whereas what we want to do is we want to dynamically pick and choose what cluster we want to talk to. So currently we are passing this information in headers. It's not very secure, and we are kind of running into challenges with application security, and we're trying to kind of figure this out. But these are some strategies we looked into. But yeah, that's a great question, and I think that's a real challenge with MCP.
Any other questions? One more? Yeah.
So thanks for the talk. I have like I've been playing around with something like this as well in the past like few months. But one thing that I noticed, like when I actually give some, like in our productions, we have like a lot of services, like it's very polluted. And the things that I learned a lot from LLM, it get too excited when it sees something. It's just like, oh, you're right, absolutely, and that kind of stuff. And sometimes I ask them about something, but since in productions you have like a lot of warning, a lot of things from here and there, like a lot of time it's actually pointing out to something that might be wrong, but not really the root cause. And that actually confused me instead of like helping me in a way to find the root cause. Because like for me, if I look to myself it could be faster. Is there like is that something that you also look into when you're actually using production systems, or is there like any tips like how you can actually utilize that? Because like at the moment that's something that I also look into. How can we actually use the LLM better in terms of like helping us rather than making us slower to find the root cause?
Makes sense. I'll kind of break this down into a couple steps, right? So the first thing that I look into such systems is you want to build like a chat-like interface and not necessarily a deep research agent, right? You want the deep research agent or the plan, execute, reflect agent to be a feature of the chat agent. So when you say, hey, can you perform this RCA for me? Only then will that agent kind of get triggered, right? And then when it comes back with the result, you should be able to ask follow-ups and also look into what has happened exactly to understand why such an answer is there. Now regarding the agent itself, like you said, production systems are very messy, right? So one way to tackle this is you build specialized sub-agents that know and interact with only a specific part of the system, right? You isolate the tools. You don't give in, like if you have 10 tools, you don't give all the 10 tools to one agent. Rather, you have one agent that has access to 3 tools, you have another agent that has access to 3 tools, and you have another agent that has access to 3 tools. Now, each of this sub-agent has been tuned and the context has been managed to solve a particular sub-problem very well. And then you eventually kind of correlate all of this, right? So I know such a system is not really is not perfect at the moment, and what I do see happening is I do see such systems improving as LLMs get smarter, but definitely look into the reasoning for why the LLM has told you a particular answer, and definitely validate its hypothesis before kind of agreeing with it, right?
Actually, one small thing. Do you measure like how much it costs? Like, because it seems like we're getting bigger and bigger. Like, is it actually cost expensive? Like, do you have any estimation on that?
I don't have an estimation on the cost itself. Again, it's a balance of how many tokens you use and how well you want your answer to be. For example, one way to save on cost is summarization, right? Again, you don't want to give all your query outputs to the LLM. But then if you summarize, you're going to lose out on some critical information because you don't really know. But you're summarizing because you want to save on tokens. So it's always a balancing act. But I don't have an answer for you in terms of cost, and I can get back to you once I do.
Thank you so much. Awesome. Okay, so